we just talked about exponential growth, and now let's talk about exponential decay. Whenever I think of the word decay, I don't know why, but I always think about tooth decay. Like, that's the first thing I think about. Sometimes I have nightmares about teeth, like I get my teeth knocked out. But anyway, TMI. All right, so exponential decay. It's probably what you think and already know that it is. Same thing. We have an exponential function of base a, f of x equals a to the x, where a is still greater than 0 and a is not equal to 1. Okay, these are never going to change whether it's exponential growth or decay. So what makes something exponential decay? Wonderful question. Let's learn by practicing. Okay, so what I'd like you guys to do is graph by hand f of x equals 1/2 to the x. Okay, which, by the way, is the same thing as having 2 to the negative x. How? Why? Huh? Well, if this is 1 over to the positive x, that's the same thing as 1/2 to the x. Beautiful, I know. Okay, so graph those on the same graph, which now I just kind of spoiled it for you. They're the same thing. Sorry, I shouldn't have done that. And then go ahead and identify the asymptotes and intercepts. Okay? So go ahead, put me on pause and do that. So here's my graph. Hopefully you guys, like I said, did this by hand by maybe plotting some values that would give you some nice whole numbers, or maybe you just used your prior knowledge of this. But anyway, we find that we have a horizontal asymptote at y equals 0. We don't have any x-intercepts, and our y-intercept is at 0, 1. Notice that these are all the same things as it is for exponential growth. And we could talk about domain and range too, and notice that they're the same as well. Okay, so notice this graph. This is called exponential decay, right? Because think about what's happening. Think about the nature of this graph. Okay, so the big question then is, using the generic exponential function, describe the different scenarios with regards to a and x that will result in exponential decay. So again, I'm asking you guys, how do you know, based off of an exponential function, if it's growth or decay, specifically in this case, decay? So go ahead, put me on pause, and we'll see if you're on the right track. Those are two scenarios. First of all, if a, the base, is between 0 and 1, so for example, 0.7, or my favorite, 1/3. I'm just kidding, I don't know why that's my favorite. But anyway, if it's something between 0 and 1, and the exponent is positive, that would give us exponential decay. Or, if a is still greater than 1, as it is in growth, but we have a negative exponent, that could also be a situation where we would have exponential decay. So, in conclusion, still knowing the difference, you know, if we have exponential growth or decay, right, increasing versus decreasing, and then make sure that we're still understanding that we have a natural exponential function and the restrictions on any exponential function.